All right, I believe we are back. So we're still on classical probability. I will give an example before we went on break. Let's do 2 more examples on that classical probability. Look at this one here. It says 2 dice are rolled. Find the probability of getting a 7, getting a, let's go 1 minute. All right, give me 1 minute, let me put this in. So getting a 7, getting the sum of 9, and the same number on both dice, and the sum of 11. Okay. So let's start with the first one. This is a classical because dice. Now, if you remember, for dice, we have this outcome. So for 2 dice, we have this outcome. So I'm gonna copy it from here, and paste it here so that we can answer this question. So total outcomes for this for 2 dice. We did it at the beginning. The total will be total or sample space possibilities. Okay, is if you count them, if you count the whole of this, you see that it is 36 of them. 6 all the way to 36. 36 possibilities. So now with this, we can answer the question. Part A says, of getting a sum of 7. This is the outcome will give us a sum of 7. Sum of 7. These are the outcomes that will give you a sum of 7. Say 6, 1. 6 plus 1 is 7. 6, 1. Okay. 5, 2. Okay.
4, 3.
Then 4, 3. Okay. 3, 4. Okay. 2, 5. Then 1, 6. So there are 7 possibilities for sum of 6. So that's probability of getting. There are 7 possibilities. How many possibilities? Let's see how many of them have 1, 2, 3, 4, 5, 6 possibilities for sum of 6. So the probability of getting, for sum of 7, I mean to say. So the probability of getting sum of 7 will be 6 out of all the possibilities of 36. Okay, 6 out of 36. And that will give you you have 6 divided by 36.
1/6.
Yeah, 1/6, which would be in decimal 6 out of 36. 0.16666, so 0.167. 0.167. 0.167. So probability of getting a sum of 7 is 1/6 as a reduced fraction, or 0.167. B part says this getting the sum of 9. Now, for sum of 9, sum of 9 probabilities are as follows. 9. This 6 and 3 gives you 9. For 6 plus 3 is 9. 6, 3. 3. Next one will be after 6, 3, we get 5, 4. Give you 9. gives you 9. Then we have 4, 5. Gives you 9. And 3, 6. 3, 6. So it's 3, 6. 3, 6. You have 3, 6. So these are the possibilities for 9. So that the probability of getting sum of 9 maybe get 1, 2, 3, 4. 4 over 36. Which will be giving you 4 over 36. 4 over 36 will be okay. I'll change this to 4.111. See, that's about basically 11%. 0.111. 0.111. C part says getting the same number on both dice. The same number on both dice. Okay. The same number. You can see them here. You can see them right here. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So how many of them? 1, 2, 3, 4, 5, 6. So the probability of getting the same number. Probability of getting the same number. Okay. Will be 6 out of 36. Or 6 over 36. We got the answer for this before. On the first example, 6 over 36 is 0.167. 0.167. See? And of course, the last one will be getting the sum of 11. So D is sum of 11. Maybe 11 will be, the sum that will give us 11 is 6, 5. And but 6 plus 5 is 11, and 5, 6. So 6, 5. And 5, 6. So the probability of getting sum of 11 will be equal to 2 over 36. 2 divided by 36.
0.0556.
0.0556.
556.
That means 5, 6 then, right? 5, 6 is good then. So that's basically, you understand the principle here. Know the sample space, know the outcome, then plug it in to the formula, you get it. So this one, you can practice this one by 5. And I have the roulette here. So you can get the numbers here and calculate it to answer this one as a practice for you, just for practice. Yeah. So let's look at what they call the basic rules, basic probability rules, and then complementary events. So these are those rules. Those are the rules that we use when we bear in mind when we solve probability. The first one is this. Rule number 1 says the probability of an event E is a number which can be either a fraction or a decimal or percent between and including 0 and 1. And this is how I write it. Probability of event A is greater than or equal to 0 and less than or equal to 1. The rule number 2 is this. If an event A cannot occur, then its probability is 0. Which means that probability of event, if it is 0, that means it's an impossible event. Now, so another way of putting it is this. The probability of an impossible event okay, equals 0. So if the event is certain to occur, and then the probability is 1. So all things being equal, the probability that there will be daybreak tomorrow is 1. Yeah. Then we have the other rules. Some of the probabilities of all the outcome in a sample space equals 1. So these are the one I want you to have in mind. We'll come to the other ones in a minute. Let me copy the rule for complement. Okay. Let's say sharing. I'll take you. So let's go back and apply these rules. So applying these rules. Now let's start with the complement. The complement of an event E is the set of outcomes in the sample space that are not included in event E. So, for example, if being in class today is an event, and not being in class is another event, the complement of being in class today is you not being in class today. So it's basically the opposite. The complement of going to work is not going to work. The complement of standing up is sitting down. So the opposite, basically. And we use this symbol here to present complement, E with a small c at the top. But E complement. So let's see. For example, here it said, find the complement of each event. Okay. For example, this one, solution. Okay. So roll a dice and getting a 4. If the complement means getting, that means not getting 4. So you mean getting 1, 2, 3, 5, and 6. Okay, that's the solution. Now this one says the complement of this event solution says writing a letter of the alphabet and getting a vowel. It means not getting a vowel. That means getting B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. See? So that's the complement, the opposite. So I think you get the point. So you can practice this to as your practice. Any question before I continue? Any question? Excellent. So let's apply the complement rule. So look at these are the complement rules here. Complement rules. Complement rules. It says, remember the complement is presented by an E with a small letter. It can be an A or E or P with a small c at the top. So probability of event E complement. Okay. Will be 1 minus probability of event E. And probability of event E equals 1 minus probability of event E complement. Let's apply it to this question here. It says here that a solution says in a lottery game, each player chooses 3-digit number between 000 to 999. That means 000, 001, 002, all the way to 999. That's about 1,000 digits. So you choose only one 3-digit. A player wins if his or her 3-digit number is chosen. Find the probability that a player buying a single ticket loses the game. So when you buy a single ticket, there's 3 digits in that game. They find the probability that you lose the game. Let's say like this. Let's use W. Our player wins wins. Now the complement is that he loses. WC player lose. Okay. Remember, this is C. So now he says, find the probability that a player buying a single ticket loses the game. Now let's find the probability of winning. So probability that he win, W, will become, according to this rule, that he wins, 1 minus probability of, that he loses. 1 minus the chance that he wins. He bought a single ticket, first of all. So the chance he wins is he has 1 chance out of 1,000 tickets sold. It's 1 over 1,000, which is you can get this from letter 1 divided by 1,000. Okay. 1 by 1,000. 0.001. This is the chance that he wins. See, this very slim chance. That's why, as I'm sure you must have noticed, most of the lottery games people will lose because the probability of winning is so slim. So now, but the question says, find the probability that a player buying a single ticket loses. So this is the complement. They are looking for the complement. So the probability of the complement that he loses, the player loses, which is the probability of the complement, is found using the formula for the complement, which is this one here. Only that we substitute W for E, 1 minus probability that he wins, which means 1 minus the chance that he wins. We found it, we got the answer as 0.001. When you subtract this, you're gonna get 0.999, or you have, or the player have 99.9% chance of losing. Okay. Any question? Question? Excellent. So there's no question. Good. Now we can look at the empirical probability, since we have done since there's no question. So in the empirical probability, we don't know the sample space. So under this that means we have to first of all calculate the sample space by doing the experiment, or observing the number of occurrences through experiment on. Then we calculate the probability of the frequency. So in this case, we use the frequency of the event and the total frequency. So which means that the formula for this will be probability of event E will be frequency of event E divided by total frequency. Okay. Okay, let's apply this to this question here. It says, hospital records indicated that the maternity patient stayed in the hospital for a number of days shown below. 3 days is the frequency. It says, find the following probabilities. A patient stayed exactly 5 days. A patient stayed exactly less than 6 days. A patient stayed at most 4 days. A patient stayed at least 5 days. So for this, first of all, let's get the total frequency. Total frequency, whereby we add all this. Okay, add all of them to get the total frequency, so that we have write it down. Have it written down. So we have this on the if we go to our calculator, add the total frequency. That's the first thing we do. So we got 15 plus 32 plus 56 19 plus 5, 127 is total frequency, 127. So we're gonna put 127 right there, 127, 127 Okay. Now with this, we can be able to answer these questions. Okay. First one says, hey, the probability probability that the patient stayed exactly 5 days. Probability of exactly 5 days. Okay. 5 days. It be equal. Now, if you look at this, how many of them stay 5 days? About 56 patients stayed 5 days. Right? 56 stayed 5 days. So you got to be 56 out of the total frequency, which is 56 by 127. Yeah, which we can go and put in 56 by 127. 56 by 127. 56 by 127 is 0.440944. So we round it to 0.441. 0.441. 0.441. So the probability that the patient stayed 5 days, exactly 5 days, is 0.441, or we have 44%, 44.1% chance that the patient stayed 5 days. How about this one? The patient stayed less than 6 days. Probability that he stayed less than 6 days. 6 days. Maybe. See, look at 6 days right here. 19. But he said less than that. So that means you can't count the 6 days. So you got the probability of that he stayed from this up. So 3 days plus the chance that he stayed 4 days plus the probability that he stays 5 days. You cannot include 6 days because he stays less than 6 days. Okay. And that will give us equal for 3 days. We got 15 out of 127. Okay. 15 over 127 plus for 4 days. We got 42 for 127. 127. And for 5 days.
Professor.
Yep.
82, not 42.
42. Oh, 32. Sorry, 32. 32. Then for 5 days, it's 56, right? 6 over 127.
Professor.
Mm-hmm.
You have plus P6 here instead of P5.
P5. Yes, sorry, my mistake. P5.
Okay.
I guess I need eyeglasses. It's time to get the eyeglass. So now let me write this down so we can compute this. I got 15 over 127 plus 32 over 127 plus 56 over 127. So let's put this in a calculator and see what the outcome will be. So I have this 15 by 127. Okay, plus we got 32 by 127. And then plus we have 56 by 127. 0.811. 0.811. So we have 0.811. Okay. We have 81.1% chance that the students that the patient stayed less than 6 days.
Professor, Professor, I have a question.
Yes,
Can you round off if it was 0.817? Can you round it off to 0.82?
Make sure.
Did you get my question?
I got 8.811. So how do you get 7?
No, I'm just asking, can you round it off if it was instead of 0, it was 6? Can you round it off to
Oh yeah,
0.82?
of course. Yeah, it's not
Okay.
it's normal rounding, yes.
Okay.
Normal
Thank you.
rounding. You're welcome. So now next one will be the patient stay at most 4 days. Now, at most 4 days means 4 days or less. So that one included 4 days. See, probability of at most 4 days. That means 4 days or less. So probability of because let's say 15 is for 3 days and 4 is for 4. So 15, 3, okay, plus probability of 4. And for 3 days, we have 15 out of 127. So we got 15 of 127. Okay, plus for 4, we have 32 out of 127. 32 out of 127. And that gives us the required probability. So 15, I'll take you to the calculator. We have it there. Okay, so we have it here already. So I'm just going to remove one of them. See, 15 over 127 plus 32 over 127. And that gives us 0.370. 0.370. Okay. Or just 37% chance. 0.37. Okay. Questions before I do the last one on that section? Any question? Okay. Say no question. Good. Excellent. Now, deeper say at least 5 days. So the probability of at least 5 days, it means 5 days or more. At least 5 days means 5 days or more. That means probability of 5 days. Excuse me. Okay, plus. Okay. Probability of 6 days. Let's see how many days we have there. We have up to 7 days. Okay. Plus probability of 7 days. So which we give us for 5 days, we have 56 out of 127. 56 out of 127. And for 6 days, we have 19 out of 127. 19 out of 127. And then for 7 days, we have 5 out of 127. 5 out of 127. And that will give us what we need. So for 6, let me write it down, then we can work it out. For 6, it means 56 for 127 for 5, actually. Then 19 for 127 plus 5 for 127. So let's calculate this. Going to our calculator. So we have, okay, 56 out of divided by 127. Okay, plus 19 over 127. So we have 10 minutes left now. 127. Okay. Right. Plus, okay. 5 right 127. So 0.6299, which is basically 0.630. 0.630. Okay. 0.630. So that answers all the questions in that section. Any query on this? Any question? Okay. So we completed at least the concept of complement and classical probability here. Classical probability, complement rule, and empirical. So any question before we move on to the next concept? Any question?
No.
Okay. And then let's look at the more rules, more concepts, and empirical. So let's look at more concepts. First concept we'll be looking at is what we call mutual exclusiveness. Two events are said to be mutually exclusive. Mutually exclusive. We have 8 minutes. Let's see if we can finish this 8 minutes. Mutually exclusive if they cannot occur at the same time. For example, one can either be a Democrat or a Republican. You know, in event being a Democrat and being a Republican, you cannot be a Democrat and a Republican at the same time. So they are mutually exclusive. So when one event occurs, it prevents the other event from occurring. Now, how about this? Getting a 4 and a 6 when a single card is drawn. When you draw a single card, if you remember our card game, if you remember our card, if you draw one card from here, either one is 6. You cannot draw one card and get 6 and 5 in the same card. It can't. It's not possible. Or 6 and 3 in the same card. So if you draw, yesterday you draw this card, which is 3. You cannot get 6 there because it is only so it's mutually exclusive. So events are mutually exclusive. One event occurs, it prevents the other event from occurring. Okay. And at an intersection, the event turning left or turning right are mutually exclusive because you cannot turn left and right at the same time. Either you're going left or going right. If you turn left, that means you can't turn right. If you turn right, that means you have to go right. You can't turn right and left at the same time. So this gives you an idea of what a mutual exclusive is. Another thing we'll be looking at is dependent event. Two events are A and B are dependent if and only if the outcome of event A affects the outcome of event B in such a way that the probability of the occurrence changes. For example, if you have a good grades, if the event grades and scholarship are independent, that means the event having a good grades and the event getting a scholarship are dependent. Since if you have a good grade, it increases your probability of getting the scholarship. If you park in a no parking zone, and then you get a parking ticket, they are dependent events. Because when you park in a no parking zone, the probability of you getting a parking ticket changes, it increases actually. So now if you draw a card from a deck and you do not replace it, it is also dependent because you did not replace it, it will now become 51 cards. So if you calculate the probability, it will affect the outcome of the probability. So sampling or drawing without replacement is a dependent event. Okay. Another thing we need to look at is the independent events. While two events A and B are independent if the outcome of event A does not in any way affect the outcome of event B. For example, if you draw a card from a deck, getting a queen, then replacing it, and then drawing a second card. See, that is an independent event because when you draw the card and put it back, you still have 52 cards. So if you want to calculate the probability of the next event, it will not affect it. Another one is this: winning a Maryland lottery and winning the New York lottery. Okay. Now, they are independent. That you win a California lottery does not mean that you win Maryland lottery doesn't mean that you win New York lottery. Okay. So now with this, we look at addition rule and the multiplication rules. I think I have them here. So these events that we just discussed here have rules we apply to them when finding probability of the event. So those rules are going to examine it when we come back, because we will soon be timed out. So we examine the rules that applies to mutual exclusiveness, dependent events, and independent events when we come back after the timing out. And we also examine even more rules, additional rule and multiplication rules. Now, let me use this opportunity to show. Somebody was asking me if I uploaded yesterday's notes. Yes, I did. If you go to files, and then you will see where it is uploaded here. Let me see. You can see it from here. I think I have a mass. See, you can see right here, Monday, December 27th. See? So those that are asking me if I uploaded yesterday's note, it's right here. Okay. Any question before I time this out, and then we'll come back for our last session for today? Any question? Okay. So in that case, I'm going to time you out. I will please log back in after 10 minutes. Okay. I see you back here in 10 minutes. Okay.